Hello everyone. The prior videos in this module have been just a brief introduction to what the course is about and to the syllabus, and those are the ones that I emailed to you. They are not strictly speaking, material for the course. You won't be quizzed or tested on that. So today, with this video, we begin the actual material for the course that will be quizzed and tested along the way. And this is our initial discussion into what science and skepticism are. What does it mean to have a scientific or skeptical view of the world? What does it mean to use science as a tool to evaluate claims, and how can a scientific or skeptical approach help you think better or more clearly about the problems that you run into in daily life, the claims that are made that you're exposed to. So let's go ahead and get started. So we might just step back for a second and ask, in general, how do you know what's true about the world? Right? Usually in a class discussion, we'll use this as a prompt and have people think about it for a moment and start riffing and coming up with the sources of everything they know or think may be true. So why don't you think about it for a second? There are lots of sources of knowledge. So some are more formal. So some of what you believe to be true, you learned from systematic, formal methods like education, right, from teaching. So some things you know to be true, you learned in class. Some you have read from books and other authoritative sources. So other kinds of sources like this could be respected newspapers, magazines, scholars, right? So you learn in part from other people whose job it is to transfer information to you. You learn from other people in more informal ways as well, right? Some things that you believe to be true come from your parents. They come from your friends. They come from other relatives. Another formal source that we didn't mention would be religious sources. So you might have learned that some things are true from a pastor, from a priest, from a sacred text in your religious tradition. You may have also learned about what's true about the world from your own personal subjective experience, right? Just from your everyday life, from the things you've seen, the things that you've heard, the experiences you've had, also teach you about what's true, right? So there are all kinds of ways in which we can come to know the world as it is, or at least as close as possible to the way the world really is. And of course, another source of knowledge about the world is science. And so we're going to focus next on what science actually is and how it comes to tell us about the way the world might be. Of course, to be a scientist, an actual working scientist, it's hard. Not everybody can do it. Not everybody wants to do it, right? Formally, to be a scientist in modern times, you need to get typically a college degree, often in a scientific field. You will typically then pursue graduate education in that scientific field, either a master's degree or potentially a doctorate degree. So in addition to 4 years of undergraduate, you may have 2 to 5 years of doctoral training. Professional scientists typically then even have postdoctoral training after that, another 1, 2, 3, 4 years in another lab beyond their PhD. And there's a lot you need to learn, right? You need to master the knowledge base within that science. You probably need to learn some mathematical skills and tools to allow quantitative analysis, which is typical in most sciences. You may need to learn other kinds of technical techniques, whether it's pipetting or how to use a microscope or how to do computer programming. There's a lot that goes into being a scientist that makes being a scientist hard. And as evidence, as tongue-in-cheek evidence for this, is this clip from The Onion, which is a satirical news source. It can often be pretty funny. In this case, they're playing on the idea that scientists have just discovered that science is hard. So the National Science Foundation's annual symposium concluded Monday with the 1,500 scientists in attendance reaching the consensus that science is hard. For centuries, we've embraced the pursuit of scientific knowledge as one of the noblest and worthiest of human endeavors, one leading to the enrichment of mankind both today and for future generations, said keynote speaker and NSF chairman Louis Farian. However, a breakthrough discovery is challenging our long-held perceptions about our discipline, the discovery that science is really, really hard. My favorite part of this is the "what the hell" on the poster on the right. So yes, being a scientist is hard, but one of the main points about this course is going to be that thinking like a scientist, adopting a scientific and skeptical worldview, at least for questions that are really important to you, can be really not only really beneficial, but fairly easy once you learn how to do it, right? So thinking like a scientist is really not hard. And I'd argue that you use this kind of thinking in your everyday life anytime you're confronted with information that you're somewhat skeptical about, right? Those critical thinking skills that scientists use kick in, and you start to think like a scientist. So that itself is not hard. It's hard to remember to take that approach often when evaluating claims. But again, hopefully this class will teach you about how that can be useful and when it may be most useful. All right, so let's talk about what science is. So I've already mentioned that on one hand, it's kind of a worldview. It's a very broad perspective about how to think about claims that are made, how to think about evidence, and what your beliefs should be based on. But it's also a method or a tool that not only scientists use, but we can also use in our everyday lives in evaluating claims. Let's focus on first on the scientific worldview. One thing that's really clear and really central to the scientific worldview is that our claims and our beliefs are based on objective evidence, right? That is not just subjective personal opinions, but on evidence. And what we mean by objective evidence is evidence that is available and observable by other people. Right? So what's in my heart isn't available for you to scrutinize. So in science, we can't use what's in my heart as evidence for a claim about the world, right? So we need to use evidence that multiple people, if not everyone, can examine and draw their own conclusions about, right? So when we make scientific claims, we're basing them on and drawing evidence for them from objective evidence, not subjective feelings. As well, what's interesting about science is that it's supposed to go where the evidence goes. So inherent in a scientific worldview is that our understanding of the world now is likely better than it used to be and probably not as good as it will be in the future. That is, in science, in the approach to science and the worldview, we take to be true that there is an objective truth out there to be known, but at any time, our knowledge of that truth is imperfect. And it can increase and change as evidence changes. So the idea here is that we get to truth by approximation. Our understanding, our grasp of the truth is imperfect, and our knowledge gets better and better as we get better and better evidence. So knowledge advances with time. So if you look at a historical, the history of science and how we've understood things scientifically, you know that what we used to be true about the world is not what we think now, right? We have a better understanding now than before. And that's because as new evidence comes in, we're willing and able to discard our prior flawed beliefs and update them to a closer approximation to the truth based on current evidence. So our understanding of the truth has to change if you take a scientific worldview. So some might see this as a weakness. Well, why should we believe what science says? It changes its mind. Well, the reason we should trust science is because we allow our minds to change when the evidence warrants it, right? So this is a strength. It's a strength of a scientific approach to say, if the evidence suggests something is true that I didn't believe before, I should shift my beliefs now. Right, so the idea again is that we are never 100% sure about the truth about the world, but over time we get closer and closer to the truth by discarding ideas that don't work anymore and updating our ideas to account for the latest and best evidence. We also, in science and taking a scientific approach, hold this truth by approximation ideal up by explicitly acknowledging what we don't know. That is, by allowing our presentation of knowledge to be to come along with expressions of error or uncertainty, right? So whenever you've seen a scientific political poll, it always comes with a margin of error, plus or minus some number of points. That is science saying up front, our best estimate for how many North Carolinians support this law is, say, 30%, but we acknowledge a margin of error around that percentage, plus or minus 2. So the real value might be anywhere between 28 and 32. So here is our best estimate with the error around that knowledge. And there aren't many worldviews beyond science that are explicit in acknowledging error, right, in showing how uncertain we might be about claims. So this is another strength about a scientific approach. Right up front, it's telling you, here are the limits of our knowledge. Right, so let's take an example of what error bars look like in a typical scientific figure. So don't worry too much about the details of this figure, although it might be somewhat interesting. This is from a scientific study of students' beliefs about certain things after they've been enrolled in a skepticism course, not unlike this one. In this study, there are two different groups of subjects in the study. There are students in control classes that don't learn about science and skepticism, and then there's a skepticism class, and their beliefs are assessed. They have strong belief in certain things versus strong disbelief in certain things, measured first at the beginning of the course, before they've learned anything, and then at the end of the course, at the end of the semester. And what do we roughly see? Well, for control classes, if we look at beliefs in psychics, alternative medicine, alien abduction, or scientific creationism, we don't see really what looks like any change in the beliefs of the control classes. In some of these domains, though, it looks like the students in the skepticism course, at least, are changing their beliefs, that their beliefs are going from more neutral to more skeptical over the course of the semester. And if we take these little bars to be the margins of error, that is, even though where the gray bar is the best estimate for the number, for the belief, right, just about 4, it might be as high as here, or it might be as low as here. Well, given that these error bars are pretty tight, right, around those values, there's not a lot of uncertainty here, and there's not a lot of uncertainty here. It really looks like by the end of the class, this control group believes more strongly in psychics and psychic abilities than the skepticism students do. Whereas that wasn't true in the beginning of the semester, right? Their averages are just about on top of each other, and their error bars are overlapping. So based on the error bars, we're able to draw some conclusions, some tentative conclusions from the study, that over the course of the semester, control students don't change their beliefs, right? Their value here is within the margin of error of the value here, whereas the skepticism students, their margin of error here is non-overlapping with here. So they drop significantly over the semester, and by the end of the semester, they seem to have beliefs that are different from the control students. So we're able to draw those conclusions thanks to those error bars. But if we change the error bars, left everything else exactly the same, our conclusions really have to change. They have to be much more tentative, right? In this case, we don't really know what the beliefs are of these skepticism students. They could be as high as up here or as low as down here. And given that these error bars overlap for the gray and the black students, right? The gray value might be as low as here or as high as here. It might even be that at the end of the semester, the skepticism students' beliefs are actually higher than the controls. When we show the error bars, we tell people how much certainty to have in the results that are presented. In this case, we're very uncertain about where the values are. So if you saw these data, you would say, we really don't know much about whether this course might lead to changes in belief for skepticism students versus control students, right? So the error bars help you interpret the results of the study. And in science, we're very upfront about what we know and what we don't know, right? Which helps people draw more appropriate conclusions from the evidence that they're presented with. Okay, as well, in science, our knowledge is democratic. That is, there aren't authorities that dictate what is true and what's not. And if you're a very famous scientist, you still have to show evidence for your claims in the same way that an undergraduate student in your field has to show evidence for their claims. So while it is true that if you're very famous, you're a famous scientist because you've done groundbreaking work in the past, you've won a Nobel Prize, the work that you do will get more attention. Humans are a social species, and that doesn't change in science. So people will initially listen to you. You have a broader platform for making claims. But ultimately, the scientific field is not going to take your claims to be true any more easily than it will the claims of anyone else. So you don't get to dictate the truth because you're influential, because you're famous, because you have a lot of grant money. You have to provide evidence for your claims in the same way that anyone else does. And so anyone in the world can contribute to scientific knowledge. You don't have to have a PhD to contribute to scientific knowledge, as long as you follow the rules of the game of science and you provide objective evidence for your claims and you follow the scientific method that we'll discuss later, then your contributions to our understanding can be just as great as somebody famous. So there's no special privileges for being famous. You don't get to dictate what's true. And so in this way, it's quite unlike many religions. So in many religious traditions, and not all, religions can vary quite a bit from one another, but in many religious traditions, there is an authoritative source of truth. So on one hand, you probably have sacred texts. And these might be written texts, they might be handed down by word of mouth over generations, but these sacred texts dictate the truth, right? What is true about the world. As well, within many religions, there are certain people that have authoritative knowledge about what's true. They might be able to make proclamations about how to interpret sacred texts or how to interpret other traditions that are held to be true. So the most obvious example might be the Pope, which in the Catholic tradition can make claims that are infallible. They come directly from God. That's about as authoritative as one could get, right? But in different sects, different preachers or prophets may be authoritative in what they claim to be true about the world, and they have special privileges for doing so, right? Not everybody that follows the religion is allowed to contradict the text or interpret the text to the same degree, right? So there are actually lots of ways in which religion is different from science. So another one is that truth by approximation point. So remember, in science, we argue that there is a truth out there to be known, but we're always uncertain of how close we are to it, and we always allow that our understanding of the truth may change tomorrow if the evidence requires it. That's not typically the case in many religions, or at least many Western religions that we are familiar with, right? There is a truth to be known, and that truth is dictated by the sacred texts or the prophets, etc. And if you don't like the way that your religion is understanding the truth, typically the religion doesn't necessarily evolve, but rather a splinter group, a subgroup, a different sect of the religion is formed. So you have all these different versions of Protestantism, right, that liked or didn't like certain aspects of the dominant form of Christianity at the time. So rather than Protestantism as a whole evolving with evidence or with change in the world, different sects splintered off. right? And so you don't see truth by approximation very often in many religious traditions. There are some where the understanding of the truth changes and interpretations of the sacred texts change with time. But in general, science is quite different from religion in both of these regards, and being more democratic, open to the contributions of many people without authoritative claims being made, and truth by approximation. Also, these terms don't make sense to you, truthiness and wikiality, yet until we watch two videos, humorous videos by Stephen Colbert from his show, The Colbert Report. I'll show you those freeze frames here of what these videos will look like. So in the doc file for this module online in Canvas, after you finish this video, the next step is to watch these two videos. They're really short clips, just illustrating contrast to a scientific perspective on the world. The first, a segment on truthiness, the second, clip on wikiality. And so please, after you finish with this video here, go to Colbert's videos, watch those, and then we'll come back and discuss them a little bit and what they say about the scientific worldview. Thanks.